On the bottom of page 17, if you want to take out your highlighter, they give us a special case of the remainder theorem. So reminder, yesterday we learned about the remainder theorem, which said if you plug in the value that makes the factor equal to 0, the answer that you get is your remainder. And the factor theorem just says if you plug in that value and you happen to get a remainder of 0, then that means that makes something a perfect factor. And that's what we're going to look at in example 2. The question is, which of these binomials are factors of x cubed minus 6x squared plus 5x plus 12? And we learned yesterday that you can find what the remainder is either through the remainder theorem or through synthetic division. The remainder theorem would, in part A, say, and again, I'm going to get you to write let p of x equal, put this in brackets. The remainder theorem says if I want to find the remainder, I could just plug in -1 into the equation, because I'm dividing by x plus 1. -1 would make that equal to 0. If I plug in -1 into the equation, I could find the remainder. And this would be a value that I probably would use the remainder theorem, because the mental math is easier. -1 cubed, -1. -1 squared is +1 times -6, -6. -1 times 5, -5 plus 12. That was very quick mental math to find the remainder. The other values that we have in this question, I probably would use synthetic division. So synthetic division would say, by the way, we're going to write here, this means x plus 1 is a factor, because we got a remainder of 0. We could have also found this out by using synthetic division. In this case, it's written in the right order. There's nothing missing, so I don't have to add any zeros. If I'm dividing by x plus 1, a -1 would come out in front. And a reminder of synthetic division. Bring down the first number. Multiply, then add. Multiply, then add. Multiply, then add. And if the remainder is 0, that also tells us that x plus 1 is a factor. So we would have both of these options to figure out whether it's a factor or not. There's something nice about doing synthetic division, because with synthetic division, the added benefit that you have is that you can write the division statement. And so what I'm going to do after this one is I'm going to write the division statement. P of x equals x plus 1 was what we divided by, and we are left with an x squared minus 7x plus 12. It has no remainder, so what we have actually done is we have factored this, or at least started to factor it. Okay? What I'm going to get you to do is we are going to, for the next ones, if I look at the numbers on the next ones, mental math-wise, it's going to be much easier to use synthetic division than the remainder theorem. And after each time that we do synthetic division, we're going to write the division statement. And I'm going to get you to leave a little bit of space after each of the division statements, because I want to talk about it at the end of this question. So before we go to part B, I'm going to leave a little bit of space here. Part B, we are dividing by x minus 3. I'm going to set up my synthetic division with 1, -6, 5, and 12. We're dividing by x minus 3. So that would mean that I would put a positive 3 on the outside. Bring down my first number, 1, multiply, add, multiply, add, multiply, add. And once again, we get a remainder of 0. That tells us that x minus 3 is a factor. So our division statement for this one, p of x would equal x minus 3, and what are we left with? 1x squared minus 3x minus 4. Part C, we're dividing by x minus 4. So again, since that number is bigger, I would go to synthetic division. I'm dividing by x minus 4. This would be a 4 outside. 1, negative 6, 5, 12. And again, I'll give you a head start. Finish the synthetic division on your own, and we'll double check to see that you've got it right. All right, let's see how you did. Did you bring down the 1? Multiply and add. Multiply, add, multiply, add. And we get that x minus 4 as a factor. Interesting, I find the textbook decided to do this. You would think by now they would have picked one that didn't work as a factor. All of these are having the same result. We're getting a factor every single time. I'm going to write the division statement for this one. This would be x minus 4, x squared minus 2x minus 3 is our division statement here. Leave a little bit of space. Then in part D, we're doing the same thing. This time we're dividing by x plus 4, so there'd be a minus 4 out front. Bring the 1 down, multiply, add, multiply, add. And finally, one that's not 0. If it's not 0, that tells us that x plus 4 the remainder was negative 168, so x plus 4 is not a factor. Yes?
I don't, like, what do you mean with, like...
When something is a factor?
No, multiply and add the...
Okay, so in synthetic division, I bring down the 1. Then these two get, negative 4 gets multiplied by 1, and we write that number here. Then we add the column up and get negative 10. That gives us a new number, negative 10. You multiply by the 4 again to give me the negative 40. And I add again. And I repeat this process. Now I multiply the negative 4 by the 45. That will give me negative 180. And then I add that up. And that's a short, you missed that yesterday. I'll put that video up. But that's a shortcut. This does long division much faster. So our division statement for this one would be p of x equals x plus 4, x squared minus 10x plus 45, and a remainder of 168 means that there's a minus 168 at the end. So if we look at everything, if I change this so we can see everything, we look at everything that we've done, we found 3 factors for this. And what's coming next is you're going to get a question that says, can you factor this completely? And because it's an x cubed, and we found 3 factors, we know that this is going to equal x plus 1 times x minus 3 times by x minus 4. And this would be factoring it completely. So you might ask, well, is this how I factor something completely? Do I have to keep trying things until I find however many would work? Does it make sense that an x squared equation has 2 factors? An x cubed equation could have 3 factors. An x to the 4 could have 4 of them, because when we multiply this out, if we multiply all the first ones together, we would get x cubed. And the answer is no, we don't have to keep guessing and checking until we find them all. In fact, the reason I got you to leave space is once you find one of them, you can write your division statement. And so, if you found the x plus 1 first, notice the division statement we wrote. And in that division statement, underneath it, can you see that you could factor it easily all the way to the end? Because x squared minus 7x plus 12, well, that would be x and x minus 4 and minus 3, and it would be factored completely. And notice when you factor it completely, you find the other factors. Now, had you found the x minus 3 factor first, it's not wrong, right? But now we could factor the rest of this one. This is going to be x and x, minus 4 and plus 1. And it's the identical factors to the first one, just in a different order. And the order doesn't matter. Same thing for the last one. You have to factor this to x and x. 2 things to 3, it's got to be 3 and 1. The 1 will be positive, 3 negative. And we get the same factors every single time. So we have to say, okay, if I can find one factor, I can use synthetic division and write my division statement, and then maybe I can factor it completely from there. Because that's our next set of questions will be, can you factor something completely? But the question that we have right now is, how do I find that first factor? They gave me 4 to try in this question, and it was nice that 3 of them worked. But what happens if I just keep guessing ones and trying ones, and they never work? Okay? Well, there is a bit of strategy on saying which factors might work and which ones will never work. So I'm going to go and I'm going to zoom back so that you can see it wider here. Okay? And I can tell you right away that if someone says, okay, Mr. JR, I'm doing this question, I'm going to try and see if x plus 5 is going to work. And I'd look at them and I'd say right away, absolutely not. X plus 5 will never work for this one. They're like, how did you do all that math so quick? I said, I didn't. I know right away that x plus 5 will not work. Well, then they said, well, what if I tried x plus 6? And I would say to them, well, x plus 6 might work. That's not a bad choice. X plus 5 is a terrible choice. X plus 6 is not a bad choice. And, I mean, x plus 6 isn't going to work because we already finished this one, and we know that the ones that are going to work are x plus 1, x minus 3, and x minus 4. But there is a hint in the original question that tells you that this one will never work, and this one's a maybe. And the hint is in the last number here, with the 12. Notice that the last numbers, when I multiply them all together, when it's factored completely, positive 1, a minus 3, and a minus 4, those all multiplied together give me 12. Just in the same way that the x's, the first ones give me x cubed. Your first ones multiplied together will always give you your first term. Your last ones multiplied together will give you your last ones. And all the mixes of the things in between will form a bunch of like terms that'll make the middle ones. But the first ones and the last ones are going to be important. And in this situation, the fact that the last one is 12, it gives you a limited amount of choices. Can you see that you could get 12 with a 1, and a 12? A 2, a 1, and a 6. So if you look at 12, and you look at all the possible things that divide 12, those will be the possible things that will work when you factor. And this is called, it's at the, this is called the factor property. So if you want to highlight this, it is at the bottom of page 18. Whatever the last number is of what you're trying to factor. So here, they're saying, you're trying to factor x cubed plus 2x squared minus 13x plus 10. These three numbers have to multiply to give you 10. So when you're testing things, you would have to test a 1, a 2, a 5, a 10, plus or minus any of those. And that's what's going to help us with our last question.